all you're gonna do is get granulocytes and red cells.
So you could somebody show us like a picture of centrifuge blood and each layer? Because I know you say it's right under the platelets, but to get that through your head as to what does that mean to my
RBC offset.
There's actually a diagram in the photoporesis operator's manual
okay,
that lists all the different cell types and specific gravities.
and where they lay in the centrifuge as we
Well,
spin.
as far as specific gravity, and then the thing about centrifuge, that's what we've used to separate, and we give more G-force to separate the different layers.
So should we go lighter or darker on our RBC offset in the cassette?
What you want to do is you want to get those red cells to the top of the cassette and just past it, but not over
Just
it. Yeah. Because part of the thing is that the data that Dr. Porrata has, that's when we were using we were not using manual monitoring. So the company came out with an M&C offset of 2.3 and an RBC offset of 6.8. When we first started using the Amicus, we collected a lot of granulocytes and a lot of red cells. And as I watched it, I could see that I wouldn't go. For one thing, I would open the valve sooner in case there's smaller CD34 cells closer to the platelets. The reason the company didn't open them sooner was because they wanted to be platelet sparing. But what I was able to prove was I was able to use the 1.5 without significantly increasing the platelet loss. So then I went on the other end, and that was not to go as deep. So that's where I came up with the 5. And so the initial data that he had, when they did that, Dr. Cataluma did the study, we were using 1.5 and 5. Now at that time, no one told me we needed lymphocytes. So what I was able to do was because we were rapidly filling up Dr. Gaston's liquid nitrogen freezers, we were using the Spectra. And the Spectra takes gigantic amounts of granulocytes with it. So you freeze them according to total white cells in there. With the Amicus, I cut that white cell dose in half by using the 5. So for a little while it was a hero, because now we were doing well.
Then Porrata came along and screwed
And
things
he
up.
now all of a sudden, now I'm the villain, I'm responsible for people not surviving as long. And so the question is, well, can we salvage the Amicus? Well, they were surprised there weren't as many lymphocytes. Now I wasn't, I knew that I purposely was stopping the collection early so I wouldn't gather the other cells. So that was the offset study that we did. And so I started out extreme, and that was as soon as the counter had the light blockage, it opened the valve. So it opened at 0. And what we found was yeah, we did get the lymphocytes, but of course we got a lot of other stuff too. And also, which was funny, going deeper also took more platelets, which doesn't make sense, except there must be another layer of platelets down by the red cells. So then I went to 1.0, and I still left the RBC offset at 7, so I'm still going deep. And with that, we were still getting the lymphocytes, and we weren't losing as many platelets. So then I compared the 1.5 and 6.8, which is the default that the company came with, to 2.3 and 6.8. And there was not a significant difference in the lymphocyte yields between those. But the key was there was also not a significant difference in the platelet loss. So that validated my using the 1.5. So I was still going to get the lymphocytes, and I at 6.8. So then the next step was to try to bring it down so we didn't go as deep into the red cells, because we're collecting a lot of granulocytes in red cells. So that's where I compared the 1.5 and 6.8 and 1.5 and 6. And in that case, things were a lot better. Had significantly less granulocytes. We're still getting the same amount of lymphocytes and the same amount as what historical to the Spectra. And we were not losing the platelets. But then as I was doing that, I noticed on some of them that the machine stopped early as I see them go through the cassette. And the red cells were still at the bottom of the cassette. And one of the things I found is that these people had high platelet counts. And then most of you have seen the blush. That's another case where if you don't do anything, you're going to lose. You're not going to get the cells. So then I did the manual monitoring technique. where I found that we make sure that we have cells all the way to the top. So this is the ultimate, because like he says, it's customized each day to that patient that day. And because this will explain why you didn't find a difference, is we looked at 200 procedures where we used the 1.5 and the 5, and we compared that to 200 procedures with the manual monitoring technique where we determined we made sure cells made it to the top. Only 40% of those actually required an adjustment. All the rest of them were able to get by with the 1.5 and the 5 setting. So I dropped the default from 6 down to 5, because a lot of procedures can be done at 5 and you're still getting good cells.
So now what happens if I'm running it at 5 and it's just like, I am red clear over
You
to
go
the,
less than 5.
go less
If you're
than
using the
5?
manual monitoring technique, and that's Kevin, you're gonna make sure you're using it, which we are, then you can go less than 5. Because
So
we're
what do you
going
say,
totally
like
by color.
4.8, 4.4,
Yeah.
or
Whatever
whatever?
it takes, so that you need to get them to the top, but you don't wanna go.
You
over
don't
it.
want that clear over,
Now, the one exception to that, which we have found out the hard way, there are a few people who have small red cells. Their mean cell volume is small. What happens with that is those red cells float up with platelets. So when we look at it, it looks like it's the right color. However, the white cells are below that. We run into these really abnormal yields. What we had to do on one of them, we actually ran the red cells all the way down to the bag before we stopped.
Is that where we should look at NCD?
Yeah.
And that 95 is usually where we're seeing them if you get.
Yeah,
down
it
to
should
the
be
80s.
probably less than 80 if it's gonna have an
Yeah,
effect.
NCD.
less than 80?
Yeah,
Maximum
and that's
of
just,
100.
just an idea. I mean, we would have to, first it has to fail. I mean, it has to be, you know, you have a lot of cells, and you didn't get them. And then you would just go darker. But yeah, that's, the bottom line is you don't wanna just go dark, because that's not going to work. And I've actually plotted collection efficiency versus mLs of red cells, and you don't, going darker just doesn't give you more cells. You put more stuff in there you don't want. And the thing is, this is not an exact science. I mean, I've been so frustrated because I've been looking at these and we've got the right amount of red cells. I mean, there's like 8 to 9 mLs. I'd like a little less than 10. Now we're around 10. So we got the right amount of red cells, and there's still a lot of granulocytes in. So there's other factors in there that we don't have control over. And so all we can do is just go by that color and do the best we can. But right now, in our collection efficiencies on the lymphocytes, out of these 10 patients, which is 36 procedures, we're averaging 50%. Now that doesn't seem like much, but it's about what you would get when you collect stem cells. And the thing is, it's CD2, which means we do not have a post-count, we just have a pre. And so that doesn't account, that assumes that your pre-count was the same all the way through. And you get a good collection, it actually drops in half. When I have post-counts, I see that. So that 50% is the minimum. So we're most likely averaging maybe 60 to 70% collection efficiency, which we probably won't get much better than that.
That's a good question, because you maximize the machine, number of collection also should grow up.
So when these patients are starting to collect the ALC, and we're getting like, they're getting like a 0.03, 0.03, 0.02, how many days is okay to keep rolling?
Sure, and that's something that we're going to work on that, because you might argue that we might do something similar to the peripheral blood CD34. You know, if the peripheral blood CD34 is less than 0.5 or so, then you stop or so. So I think one thing, as we gather a little more data, we're going to come across with that. My bias will be right now, if based on what we see, at least for 0.3, which is, even though we put 0.5 in the order, 0.3 is the lower cutoff. The median is being 5 collections. So, I mean, one argument could say just do 5, because I know for the patient, I mean,
They get very anxious.
they're very anxious, and they already collected, you know, like 12 million CD34, maybe that would help our stay in the hospital and graft faster or so. So maybe we can come in those slow collector, maybe do a maximum of 5 collections and start with that.
And they'd love to get Porrata or something to motivate the collection process, like you said, Porrata
Yeah.
motivates that
Yeah,
labor.
and we can say, because Ed have data that when they're on G and Plexiport, usually the ALC is like 0.1 or 0.15 or so. But when we stop, definitely drop.
Because they all know it, and they all say, why
So,
do you quit? Why do you
how long would it take to, convince the insurance companies that
That's gonna be, yeah.
that, I mean,
quit?" Would they
that's your
rather pay for
obstacle?
collections or-
Yeah, well, that's something that I think is gonna be an obstacle. Right now, Plexiport is being approved for just the collections of CD34. It might be the case that we might have to do other studies comparing Plexiport versus non-Plexiport. Because, there are some patients that we still collect the ALC on G alone.
Sure.
With that, and then to present that. But there's definitely data that Plexiport can mobilize lymphocytes. And there's also some data that might mobilize also NK cells too.
And so for those patients that we collect the CD34 target on like the first or second day, do we do like 3 or more consecutive to get that ALC? Each day that CD34 number of which we have collected is going up and up and up.
Mhm.
So a lot of times the patient says, well, now my CD34 is astronomically more than what my goal is. Are we still reassuring them that all that CD34 is still filling our freezers and it's there for them
Yeah.
if they need that? Because that's a question.
Yeah,
that
and
we
usually for
have to ask.
lymphomas compared to myeloma, which is a different kind of fish, everything that we collect, we give them back. So we don't save anything in the freezers.
That's a lot of DMSO and stuff.
Well, there's been also some case reports of people have what they call super C34 mobilizers that get given doses of 10 or 12 million. They still do very well with that. So in lymphoma, that's the beauty about lymphoma, everything, you only collect for 1 transplant, so wherever we collect, we give. Once I think eventually it's transferred to myeloma, that's gonna be more difficult because if they collect, 12 or 13 million, whatever, but they collect to do 3 or 4 transplants. So the catch-22 is gonna be, do we have enough ALC for each transplant? Or we're gonna put all the marbles in the first one, not the second one, so forth. That's something down the line. But lymphoma, the reason we wanted to do the lymphoma is simple or straightforward, everything that we collect, we give. We don't hold anything back.
And that was my question about myeloma. So when you share that data and you indicate that you're gonna move to using that ALC for
I think
myeloma,
eventually that will be coming up.
but we're gonna have to record the amount of ALC on each individual unit and record the
Yeah.
CD34 cells and then mix and match which each individual transplant to meet both the CD34 target and the ALC target for each one as well.
I will foresee that's not gonna happen soon. If it happens, it will be several years down the line. The DISPO group is also interesting about this because we published data, I also show you all the institutions that confirm the findings.
How many transplants do you actually do more than you go up to 3?